Welcome to MySQL Lesson 10. This is a tutorial on how to use your workbench for data modeling. The first thing we're going to try to do is reverse engineer a database that we've already created. So open up your workbench and let's get started. The MySQL workbench includes modeling that allows you to create an EER representation or model of an existing database. To begin this process, click Database on the toolbar, and then click Reverse Engineer. It will first connect to your server just like a query does. So click the Next button and go to the next page. When the connection has completed, click Next again. On this page, click SampDB. This is the sample database that was created for this course. Click Next to retrieve the database definitions. Click Next again, and you will see the imports that are going to be created for the table objects and view objects. There should be 9 tables and 2 views. Click Execute to continue. Here, it will create an SQL script. Click Next, and you can review the objects that were just reverse engineered. Click Finish, and the next screen will be the actual EER diagram. This model is an industry standard Enhanced Entity Relationship Diagram, also known as an EER diagram. Click and grab the title of each table or view so that you can rearrange them. By rearranging them, you can see them better. They kind of stack on top of each other when it's created, so here you can see all the tables with the 2 views. The body of each table shows the variables and the types that are defined for it. The blue labels are for tables. The yellow labels are for the views. Once you're satisfied with this diagram, you can use the Save Model As to preserve it. It will automatically go to the folder for your Workbench program. However, you might want to create your own folder to organize your model files. Save it. After you save your model, you will see the model overview again. For the body of each table, if you click the button down at the bottom under Indexes, you can see the indexes for that table. Notice that there's also a line between them to illustrate the connection. Since both the member and apothem tables are standalone, there are no lines to connect them to any other tables. However, member does have an index, which is member ID, but apothem has none. With further exploration of this diagram, you can also see the catalog tree to the left showing how a table contains all of these columns. This is the absence table, which contains student ID and date. And this is the student table that is connected to grade event, scoring, and absence, and it contains the name, sex, and student ID. By clicking on either of the views, I can see its definition down below in the window where we were seeing the actual table members. And it's the entire definition of that view. For instance, vStudent, there's the information. Another really nice feature of the modeling tool is the ability to export files in a format that users can view, such as .pngs or .pdfs. From this model overview, you would click the File menu button, then click the Export, and finally export as a .png. Type in the name you want to save it as, then click Save. Additionally, you may want to export a single-page PDF. Also, again, click the File menu button, then Export, and export as a single-page PDF. If you go to Windows Explorer, it will be showing up as an Adobe Acrobat file, and it can be opened by Adobe Acrobat Reader by double-clicking it. And there it is. Both of these files we saved are standard format that most people can open and use. Here's the .png file that can be opened with a Windows image viewer. And then here is the .pdf file that can be opened with Adobe Acrobat. So now you have the ability to create a model of your database in a diagram. and share it with others in a standard format. You may recall the example in your textbook for foreign keys and referential integrity. That was Chapter 2, Section 2.14. For this demonstration, you can take a look at the parent and child tables. These tables have many-to-many relationships, so I wanted to illustrate how this diagram shows this type of relationship. One child can be related to many parents, and one parent can be related to many children. The connector is used here to signify many-to-many. To remind you of how these database tables look in Chapter 2, I've done a query of the two tables here. First, I'm going to query the child. From the query, you see that parent ID 100 is linked to child IDs 1, 2, and 3. And also, child ID 1 is linked to two different parent IDs, 3 and 100. That's a many-to-many relationship. The child keeps track of the references, not the parent. And this is the query of the parent. Let's take a look at the Eer diagram again and look at how these relationships are illustrated. The connectors used in the diagram basically have two categories: either an identifying relationship or a non-identifying relationship. The identifying relationship is a case where the child table cannot be uniquely identified without its parent. This means that the child contains information directly derived from a parent, such as the parent ID that we saw in the query, where parent ID was part of the child record. In a non-identifying relationship, that doesn't have to happen. The identifying relationship is indicated by a solid line, whereas a non-identifying relationship uses a broken line. So here are each of the connector icons located on the left side of this page. Here's a connector for a new non-identifying relationship that is one-to-many. This connector is a new identifying relationship that is one-to-one. The connector below it is a new one-to-many identifying relationship. You might have noticed that some of the relationships show a little multiple indicator on one side where it doesn't show up on the other side. The multiple indicator looks like little crow's foot, and that indicates many. When it's not there, that indicates one. Now, based on that information, it's pretty easy to see that this is a many-to-many, and also it's an identifying relationship because it's an unbroken line. A solid line indicates an identifying relationship. And it looks like I missed the one at the very top. That's the simplest of the relationships that you are using here. A new non-identifying relationship that is just one-to-one, and it is shown by using a broken line with no multiple connectors on either side. That's one-to-one. There are a few more buttons on the left side that you might use when you're establishing new tables, and actually we're going to use one of those in the next video. So close out this demonstration and move on to the next video that shows you how to create a new database model.